Okay, now that we have found standard error and worked with confidence interval and hypothesis testing for a single proportion, we're going to do the same thing for a single mean. So there were 855 Major League Baseball players in 2012, and their mean salary was $3.44 million with a standard deviation of $4.7 million. If we take random samples of size 30 players and calculate the mean salary in millions of dollars for each sample, describe the shape, center, and standard error of the distribution of sample means. So the shape will be bell-shaped. The mean will be that $3.44 million. And the standard error is standard deviation over square root of n, so 4.70 over square root of 30, which is 0.858. Now, for mean, we can't use the normal distribution that we use for proportion because we rarely know the population standard deviation. So we're going to use another distribution similar to the normal, known as the t-distribution or the student t. So it's going to change what we use on our calculator. So now we want to find the endpoints of a t-distribution with 5% beyond them in each tail if the sample has size n equal 18. Well, the thing with the t-distribution is the values change based on the sample size. So we still have our mean in the middle. We have a minus z and a plus z. There's 5% beyond them in each tail. So there's 5% in this tail and 5% in this tail. So basically, we need this whole area. So this whole area is going to be 1 minus 0.05, or 2 times the 0.05, because we want this part in the middle. Or actually, no. That's making it harder. 1 minus 0.05 will give us the total area to the left. And we're going to use inverse t. Area to the left is the 1 minus 0.05. And now we have to include degrees of freedom. Degrees of freedom is n minus 1. So 18 minus 1 is 17. So we go back to the second vars. Inverse t, you may or may not have it on your calculator. If you do, it's option number 4. So the area is 1 minus 0.05. Degrees of freedom is 17. And we have a cutoff of 1.74 or 1.7396. So the positive is 1.7396, and the negative is a negative 1.7396. Now we want to find the area in a t-distribution to the right of 2.3 if the sample has a size of n equal 15. So again, here's our distribution. Here's that 2.3. So it's going to be the lower limit. So we have T, CDF. Lower limit is 2.30. Upper limit 999, and our degrees of freedom is 14. TCDF on mine is option 6. So we have 2.3 as the lower limit, 999 as the upper limit, 14 as the degrees of freedom. And we get 0.0187. Now we want the area in a t-distribution to the left of 1.22 if the sample has a size of n equal 50. So here's the 0, here's the 1.22. We want everything to the left. So it's TCDF. Now 1.22 is the upper limit. So negative 99 is the lower, 1.22, and degrees of freedom is 50 minus 1, or 49. So we have second vars and TCDF. Negative 99 is the lower, 1.22 is the upper, 49 is the degrees of freedom. We get 0.886. Now we want the area to the right of 2.3 if the sample size is 15. However, we just did that one, so we don't have to do it again.